the previous videos, we have discussed about various types of losses, which include the short-term losses and the long-term losses. So far, we have discussed about the three short-term losses. Their existence are based on various types of pre-stressing methods. Now we're going to look into the long-term losses. These long-term losses is regardless of the method of pre-stressing, as all the pre-stressed members should undergo these long-term losses. First, let us look at the shrinkage loss. We know that the shrinkage is due to the contractions of the concrete as a result of the loss of the free water. Such contractions cause the losses of the pre-stressing load in the steel tendon, and thus over time some degree of losses of the pre-stressing stress in the member will occur. This slide shows the equations for the shrinkage loss. The equations is given here, which is in the functions of the epsilon and modulus of elasticity and also the area of the steel tendon. We know that the shrinkage losses supposedly is referring to the concrete. However, when we want to quantify the losses, we are quantifying the stress in the tendon, assuming that the shrinkage of the concrete will be same as the change in terms of the strength in the steel tendon. This is represented by epsilon CS. The equation here is in the functions of the force, as epsilon E here represents the stress. Stress times the area will be equals to the force. The shrinkage strength in the steel is given in the equation here, where you need to obtain the epsilon C naught as given by this formula. There are two factors here, which are the alpha ds1 and alpha ds2, which can be referred from this table, dependent on the type of the cement used. For the cement type S, alpha ds1 and alpha ds2 will be 3 and 0.13 respectively. If cement type N is being used, the factors will be 4 and 0.12. If cement type R is being used, the factor will be 6 and 0.11. Within the functions, there is FCM, which represents the mean compressive strength of the concrete. FCM can be calculated from FCK equation here, the characteristic compressive strength plus 8 megapascal. You will need to substitute the relative humidity in the equations, which is quantified in terms of the percentage. Next, you need to determine the factor KH. This KH will need to be defined from the H note in reference to this table here. The H note is given by the equation here. You will need to first calculate the H note in order for you to determine its KH. The equations for the H note will be the cross-sectional area of the sections divided by the perimeters of the sections in contact with the atmosphere. By calculating this H note, determine the KH based on the interpolation method. Substitute into the equation here for you to obtain epsilon CS. The modulus of elasticity of the steel is equals to 195 megapascal, and APS here represent the areas of the tendon. It is calculated by multiplying the numbers of tendons times the area of each tendon.